In this video, we will work on simplifying trigonometric expressions. Here, we notice that cosecant is 1 over sine, so we can substitute that in. Then we notice that cosine t over sine t is the same as cotangent t. And done. Next example. Here we notice we can change secant t into 1 over cosine t. Then, to simplify the complex fraction, we can multiply the top and bottom by cosine t. Then recall that 1 minus cosine squared is the same as sine squared. Then we cancel one of the sine t's, being left with cosine t over sine t, which is the same as cotangent t. Side note, not all problems simplify to cotangent t. This was purely a coincidence. In this example, we note that cosine squared plus sine squared is 1. So this expression simplifies to sine squared. And done. If we want to not have a squared term, we can rewrite this using the identity sine squared equals 1/2 times 1 minus cosine 2 theta. Note, this really isn't needed, but it is good to practice to recognize possible identities when you can. Another example. First, we see we can factor a cosine from the denominator. Then we can split this up a bit as sine over cosine times 1 over sine squared, since 1 minus cosine squared is sine squared. We now can cancel one of the sines, and we're left with 1 over cosine x times 1 over sine x, which simplifies to secant times cosecant x. Next example. We distribute the terms, then write cosecant x as 1 over sine x, and cotangent x as cosine x over sine x. Then we notice one of the terms, cosine x over sine x, is just cotangent x, which cancels out with the other cotangent x term. Now we just have 1 over sine x minus cosine squared over sine x. Then we add the numerators with sine on the denominator. Remembering 1 minus cosine squared is sine squared, we end up with sine squared over sine, and that simplifies to just sine over x. Now let's play with some examples involving some sum and difference identities, which are listed on the left side of the page. Note, for the following examples, we can use either sum or difference identities. A good exercise would be to try to verify our results by using their corresponding sum or difference formula. For sine 105, we can split this up using the sum identity, rewriting it as sine 45 plus 60. Then rewriting using the sum identity on the left. Then we just simplify using common values for trig functions. Reminder, you can verify this result using the difference identity instead of the sum identity. For cosine 75 degrees, I will use the difference identity, though it is actually easier for me to see using the sum identity. So first, we split this up as a difference of two angles, like cosine 135 minus 60. Then label A as 135 and 60 as B. Then plug into the difference identity. Recall that 135 degrees has a reference angle of 45 degrees and is in quadrant 2. So cosine of 135 will be negative root 2 over 2. Sine 135 degrees is positive root 2 over 2, and we just simplify our result. Again, you can show that this is true by using the sum identity as well. For the next example, I will split it up as a sum of two angles. Tangent of 3 pi over 12 plus 2 pi over 12. Which then simplifies to tangent of pi over 4 plus pi over 6. Then label pi over 4 as A and pi over 6 as B, and plug into the corresponding sum identity. Then we plug in values for tangent of pi over 4, which correlates to tangent 45 degrees and equals 1. And tangent pi over 6 correlates to tangent 30 degrees and is equal to root 3 over 3. And we then simplify. We can simplify first by multiplying top and bottom by 3 to get rid of fractions on the numerator and denominator. Then we multiply by the conjugate, 3 plus root 3, to get rid of the radical on the bottom. Then continue to simplify from there. Enjoy some motivational music while I write. And done. For this example, we notice it is split up into cosine of a sum. So we can use a sum identity to simplify. Since 7 pi over 4 is in quadrant 4, cosine of 7 pi over 4 is positive root 2 over 2. And sine 7 pi over 4 will be negative root 2 over 2. In this example, we can simplify the left side of the equation by using the difference identity for sine a minus b. So let's rewrite it like that, where a is 8x and b is 6x. So we can write the left side as sine of 8x minus 6x. Then simplify the equation to sine of 2x being equal to 0.85. Then we get the 2x term by itself by rewriting the equation in inverse notation. Divide by 2 to get x by itself. Then using the calculator, we get x is about 0.5080 radians, or 29.106 degrees. Here are a few examples that can be simplified using the double angle formulas. First, we start with sine 2a, which can be replaced with 2 sine a cosine a. And sine a is 7 over 11, and cosine a is 6 root 2 over 11. So plug these values in and simplify. Now let's find cosine 2a. We can use any of the three listed on the left side of the page. I will use the first one just because I want to. So cosine 2a is the same as cosine squared minus sine squared. Then we just plug in our known values and simplify. Now for tangent 2a. First let's find tangent a, which is just sine a over cosine a. Now to find tangent 2a. It is 2 tan a over 1 minus tan squared a. Then we plug in tan a and simplify. Simplify the complex fraction. Let's multiply 72 root 2 to the top and bottom, since it is the LCD and will make it easier to deal with. And done.